So the function g has derivatives of all orders, and the Maclaurin series for g is given by this series. Using the ratio test, determine the interval of convergence of the Maclaurin series. So the question says use the ratio test, right?
Yes.
Okay. The one we are given is an or an plus 1? An. To use the ratio test, you need an and an plus 1, right? Okay. So the given one, n equals 0 to infinity of negative 1 to the power of n
X to the power of 2n
2n
plus 1
plus 1
over 2n plus 3.
2n plus 3. This is an. Now we need an plus 1 by doing what?
Add 1 to all n.
N equals 0 to infinity
Minus 1
to the power of
n plus 1
n plus 1
x
x
to the power of 2
to
then bracket
bracket, there you go,
n plus 1
n plus 1
and close the bracket plus 1.
plus 1. We're adding 1 only to n, okay? All over
2
2
bracket n plus 1
n plus 1
plus 3.
plus 3. This is an and this is an plus 1, right? Okay, so let's find the limit of the ratio. Part A, the limit as n approaches infinity of n plus 1 over n, which is the limit as n approaches infinity of, we can do KCF, right? So we start with A1, an plus 1, I mean, negative 1 raised to
n plus 1
n times negative 1 raised to 1, right?
yes.
And then you have x raised to what?
2n
2 times n? 2n times x raised to what?
to 2 then
2 times 1?
2
2 plus 1?
to 3.
3. So this is going to be x cubed. All over. Let's simplify the denominator. 2 times n?
2n
2n. So let's write 2n.
then 2 plus 1
Plus 5. 2 plus 1 is 2 plus 3 plus 5. So this is going to be multiplied by the reciprocal, right?
yes.
We write here
2n plus 3
2n plus 3, negative 1 raised to n, and
x to the power of 2n
And
plus
what?
x to the power of 1.
x to the power of 1.
Cancel the
Let's cross them out. So negative 1 raised to n, negative 1 raised to n, and we can cancel also negative 1 raised to 1. Why?
because absolute value.
There is an absolute value, so it's going to be positive, right? X raised to 2n, x raised to 2n. This x with this cube becomes
Square.
squared, right? So let's write what is remaining now. The limit
It's n approaching infinity.
n goes to infinity.
Then
X what?
x squared
X squared
times
times
2n plus 3
2n plus 3,
over 2n plus 5.
2n plus 5. So this limit is equal to what?
X squared.
X squared, right? Because we are just looking at the ratio of the coefficients here. It will be 2 over 2, which means it's 1. 1 times x squared. So this is the absolute value of x squared. And to converge, you need this to be
less than 1.
less than 1. That means x is between what?
Minus 1 and 1.
Minus 1 and 1. So this is the interval of convergence, but we need to check now what the end points, the -1 and the 1. Are they included? Do they make this series converges or not? So we need to check them. So what happens if we plug in
X equals 1.
so if x equals -1, okay? We did it differently in last week when we did this question, right? Now in this session I will do it like what the AP is doing, okay? So x equals -1. What if we plug in -1 here instead of x?
Minus 1.
Here. -1/3, right?
Yes.
Comma? Not comma, sorry. It's not a sequence.
Minus 1 cubed.
Okay, minus -1 cubed.
5.
-1 cubed is -1, so it becomes what? Plus 1/5 minus 1/7, right? Plus 1/9 and so on. Okay? So if you plug in x equals 1, what's going to happen?
1/3
1/3
minus 1/5
plus
1/7
1/7
minus 1.
minus 1/9. And both series are alternating series, and they are decreasing. If we take their absolute value, they are decreasing, okay? And the limit of n as n approaches infinity will be 0. So in this case, both what? Converge by which test?
By the ratio test.
By the alternating series test. So if both converges, that means we can just include them in the interval, right? So we just include them in the interval. So the interval goes from -1 to 1, both are included. So the interval is from -1 to 1. But this is the Maclaurin series for G evaluated at x equals 1/2 is an alternating series whose term decrease in absolute value to 0. That means when x equals 1/2, the series converges. It's going to be an alternating series whose term decrease in absolute value to 0. That means the series when x equals 1/2, the series converges. And 1/2 actually it's in this interval, the interval we found in part A. So 1/2 is the value of x. The approximation for g of half using the first two non-zero terms. This is important. The first two non-zero terms of this series is 17/120. show that this approximation differs from G of half by less than 1 over 200. So we are looking at the alternating series error bound, the alternating series error bound. We are using what? We are using two terms. So the error bound is at most, which term? The third term. Okay. So G of, okay, this is bar 3. This is G of 1 over 2. This is the actual value of G of half. Okay, this is the actual value minus the approximation. What's the approximation? 17 over 120. The difference between the actual value and the approximation is the error, which is the remainder, right? So G of half is the actual value. 17 over 120 is the approximation. Okay? The difference between them is the error, and this error is at most A3, which is the third term, because we use only two terms, so the error bound is the next term, or the first unused term. So what is the first term? The first unused term, we use 1, 2, so it will be what?
X to the power 5
Over 7. X to the power 5 over 7. What's the value of x?
1 over 2.
1 over 2. So this is going to be what? 1 over 224. If anyone has the calculator, 1 over 224. 1 over 224, which is this term, 1 over 200. So our approximation is less than, approximate the value with an error less than 1 over 200. Write the first three non-zero terms and the general term of the Maclaurin series for G prime of x. Write the first three non-zero terms and the general term of the Maclaurin series for G prime of x. Okay. For part C, we need to find the first three non-zero term and the general term of G of the Maclaurin series for G prime. This is for G, right? The given one, it's for G. Okay, so we need to find the first three non-zero term of the Maclaurin series for G, right? So we just need to differentiate the terms individually. So what's the derivative of x over 3?
1 over 3.
It's just 1 over 3 minus The derivative of x cubed is what? 3x,
Squared.
but over
5.
5 plus
5x.
5x to the power of 4 over 7, and so on. But what will be the general term? يعني if we differentiate this one here, what do we get? This is called the general term. We are differentiating with respect to what? With respect to x. So anything with n will be the same, right?
Yes.
Meaning here negative 1 raised to
And
n will be the same. The denominator
2n plus 3.
2n plus 3, it will be the same, right? Okay? Now we just need to differentiate this x raised to 2n plus 1. And 2n plus 1, consider it as a number. So how do we differentiate, for example, x squared? 2x, yeah, we put the power in front. So let's write the power. What's the exponent here?
2n.
2n plus 1. And then you will reduce the power by what? By 1. So 2n plus 1 minus 1 will be 2n. So x raised to what? To 2n. Plus or minus doesn't matter. This is the general term, and these are the first 3 terms for g prime of x. Understood? So the answer key, 5 marks for the first part, which is the interval of convergence, 1 point for the ratio, 1 point to find the limit of the ratio, which is x squared, 1 point for the interior of interval, meaning from negative 1 to 1, and 1 point for considering the 2 endpoints, negative 1 and 1. And then you have to say that the interval goes from negative 1 to 1, both are included like this. The second part we are looking at, here again, when you consider x equals negative 1 and x equals 1, you can just list the terms and say that they are alternating series, they are going to converge. The second part, which is the third term, 1 point is earned for uses the third term, and 1 point will be for the answer. For part C, you are differentiating 1, 2, 3 terms, and the general formula or the general term has another point. So 1 point for the 3 terms and 1 point for the general term. Clear?
Yes.
Okay, another question, question 2.